Hello dear students, today we're going to talk about fluids, specifically about the Pascal law, which says that if external pressure is applied in a confined incompressible fluid, it's transmitted equally in all directions throughout the fluid such that the pressure variations remain the same. And you will ask yourself, what does that mean? Well, we have an external pressure, let's say in a confined fluid, let's say a bottle with water. And the external pressure will be a piston with K newtons. The incompressible fluid, let's say it's almost all the fluids in the world, let's say it's water. The pressure will be transmitted in all directions throughout the fluid such that the pressure variation remains the same. This means that the pressure of these K newtons will be transmitted all over the surface of the bottle with K newtons of pressure. Well, the equation of this is F1 over A1 equals F2 over A2, or P1 equals to P2. This is very useful in the hydraulic pressure. Let's think about an hydraulic cat which has a certain area here, and we apply certain force. Well, this will be equal, and we will move the incompressible fluid and the volume such that will be equal to the force 2 over area 2. This is very useful in most of the cases.
Okay, here's a little example. So let's suppose we have an hydraulic press, should be a little like this. Yeah, this is going to be our area 1, this is going to be our area 2. As we know, our formula is force 1 over area 2 equals force 2 over area 2. Sorry, here's a little error. So let's suppose this have a 5 centimeter diameter, and this is a 60 centimeter diameter. So first of all, we need to calculate our areas as we have it in centimeters. So like it's a circle, we have to use P times R square. So we have area 1 is going to be P times 2.5 centimeter because it's diameter over 2 square, and this is going to be 19.63. That's our area 1. And for our area 2, it's going to be the same. We just change 2.5 for 30 centimeter square, and that is 2827.4. And let's suppose we have an output force of, I don't know, 9,000 newtons upwards. So what is going to be our input force? Our force 1. So we have to look out for force 1. So force 1 is going to be force 2 times area 2 over area 1, over area 2. We just have to substitute the values with, so to force 1 is equal to our force 2, which is 9,000 newtons, times our area 1, which is 19.63 centimeter square, over area 2, which is 2,827.4 centimeter square. As we're going to use both areas as centimeter square, it doesn't matter if it is in centimeter square or meter square. They're gonna cancel each other, and we'll have the same resultant force. So 9,000 times 19.63 over 2,827.4 is going to be 62, approximately 4.48. This is going to be our resultant, our input force, as in newtons. So we have to apply a 62.488 newton input force to have an equal output force, to have an equivalent output force in the other side of our hydraulic press. And that's pretty much it.